Hello. Today we are going to talk about how to write equations in factored form. We'll do a little warm up, making sure you know what factored form is and all the pieces of it. And then afterward, we will write equations given specific values. Okay. So we have three forms of a quadratic. Today we are going to focus on factored forms. So this is what factored form looks like. It's when you have those two groupings, right? So a times x minus a value, and then I have a second grouping of x times a value. All right. So we're going to go through this. This is kind of what information is given here. So when you're given something that's in factored form, these values that are in the parentheses are in fact your x-intercepts. Okay, so these values are your x-intercepts. So when I ask what the zeros of this function are, that's just another word for x-intercepts. I know I'm going to do the opposite. Always opposite, guys. When you're in those parentheses, we're always going to do opposite because the formula, again, is minus R1. That tells me to do the opposite of R1, and minus R2. That tells me to do the opposite of R2. And then the other one would be a negative 4, comma 0. So again, I did the opposite. All right. So I have a few of these, so you can practice. Again, looking at the parentheses, when you have two groupings like that, it tells you the two x-intercepts. Okay. So let's take a look at the next problem. So I want to know where the zeros are for this function. So feel free to pause or write it down. I'm going to go ahead and do it on my screen. I know the x-intercepts, or the zeros, are going to be at a negative 8, comma 0, and a positive 6, comma 0. All right. Now, what about from a graph? Can you get the x-intercepts from a graph, or the zeros from a graph? Well, if I'm looking for the zeros and I'm given a graph, I want to know where it hits the x-axis. That's what an x-intercept is, or that's what a zero is. So if I look at this, my x-intercepts are going to be at negative 4, 0, and over here would be at a positive 3, comma 0. Right? So if I give you a graph and I ask you for the x-intercepts, you're just looking for where that graph crosses the x-axis. Continuing on, where are the zeros for this quadratic function? Well, same. Where does it cross the x-axis? So I get a negative 2, comma 0, and a positive 5, comma 0. Those would be my two x-intercepts, or my two zeros, right? I have one more. What are the zeros for this function? So I have one at negative 7, 0, and I have one at a positive 2, comma 0. Okay, so hopefully given a graph, you can now identify the x-intercepts or the zeros. But how about writing the equation for that quadratic, right? I want the equation for that red curve. So I have the next few slides talk about how to write the equation using the formula at the very top of the slide here. We're going to find the x-intercepts. We are going to then find the a value that's inside, and we're going to write the equation for this quadratic, okay? So here is my first graph, okay? I want to write the equation for this. Now, when I do it, the first thing that I want to do is I want to find the x-intercepts, okay? So let's start. We're going to use factored form. Okay, so this is the formula for factored form, and I want the x-intercepts. Well, I know my x-intercepts are going to be at a negative 3, 0, and a positive 1, 0. Now, not only do you need the x-intercepts, but we are going to need another point. So just like when we did vertex form, we need the two x-intercepts and we need a separate point. You can pick any of these other green points. I'm going to pick negative 2, comma 3. Okay. So once we have that information, I'm going to start by putting the x-intercepts to my problem. So I'm going to say x minus my first x-intercept. So x minus a negative 3 is really plus 3 because Remember, we're doing the opposite, and if you subtract the negative, it becomes positive. And I have x minus my second x-intercept, which is minus 1. So after I plug in those x-intercepts, then I'm going to substitute in my other point. And just kind of a recall from when we did vertex form, that other point tells me an x and a y value. So the y value is going to be the 3. The x value is a negative 2. Now you have to be careful because there's 2 x's. So each of those x values becomes a negative 2. So now when I solve this, I'm going to get a times negative 2 plus 3 is 1. Negative 2 minus 1 is a negative 3. I get 3 equals. Now, this is all being multiplied together. So I can multiply those two values. 1 times negative 3 gives me a negative 3a. And then I'm going to divide the negative 3, and I get a to be a negative 1. And that is my answer. Okay, so to write the quadratic for this, I know the quadratic is a, which is my negative 1, x minus my first x-intercept, which was a negative 3, so we put a plus 3, and then the second x-intercept, which we'll say x minus 1. Okay, now I know that was a lot. I have a few of these examples. We'll do them all. Okay. But we're going to find the x-intercept. We're going to find a second point, okay, or actually a third point. And then we are going to substitute those values into the appropriate places, so pay attention to that. And then we can simplify, solve for a, and write our answer, okay? So let's take a look at this next one. So I have x-intercepts at these two values. So I'm going to start with a, x minus r1, x minus r2, and I know my x-intercepts are at 1 comma 0 and at, where's that last one at? 5 comma 0. Okay. And I need another point. So you have to look at your graph. You have to find another point that your graph hits very nicely, like on the grid marks. So you could use this point, you could use the vertex, you could use this point. I think those are the only ones that I see that come out very nice. So I'm going to go ahead and use the vertex. I think that's a pretty good point. So that's at 2, 3, 4. So that's at 3 comma 4. So my extra point is going to be at 3 comma 4. So if I plug those values in, I'm going to say y equals, I'm going to start with the x-intercepts. I like to just start slow. So x minus my first x-intercept, which is 1. X minus my second x-intercept, which was 5. So now I can plug in my point. Remember, x comma y. So the y is 4. The x is 3. So everywhere there's an x becomes a 3. So now I'm going to simplify and I'm going to solve. So I'm going to get 4 equals a. 3 minus 1 is 2. 3 minus 5 is a negative 2. And I get 4 equals. Now you can multiply these together. 2 times negative 2 is a negative 4a. Divide the negative 4. And I get a to be a negative 1. Now, it's pure coincidence that we got negative 1 again. It is not always negative 1. But my equation of this quadratic is going to be negative x minus my first x-intercept times x minus my second x-intercept. And this is the equation for my quadratic. Okay? So, again, the steps, write your formula. Find your x-intercepts and a point. Substitute in the x-intercepts and the point to find your a value, and then write your answer. Okay? I got another one. We got a bunch of these. So I'm going to start with my formula. Y equals a, x minus r1, x minus r2. Feel free to pause the video. You can try to do it on your own if you like. Okay, if you need a little help, you can follow along. I'm going to then find my x-intercepts. Which are at -4, 0, and 1, 0. Then I'm going to find another point, something that hits the grid lines pretty well. This is a pretty good point here. Let's use a different color other than red. So that's a pretty good point. You could also use this y-intercept. Looks pretty nice. It hits at a nice value. Let's use a y-intercept, 0, -1, right? That's a nice point to use. All right. So now I can substitute in my x-intercepts. So let's do that first. So I'm going to say y equals ax minus my first x-intercept, which is -4. Now, if you subtract a -4, that's +4. Remember opposites. X minus 1. So it's a +1. Now I'm going to plug in my other point. Remember x comma y. So the y value is a -1. The x value is 0. So if I start to simplify this, I get 0 plus 4 is 4. 0 minus 1 is a -1. If I combine 4 and -1, that gives me a -4. Excuse me, that looks messy. Let me try to rewrite that. And go ahead and divide the -4. So that gives me and if you divide, I got my calculator here, but if you take a -1 and divide it by a -4, you get a positive 0.25 or a positive 1/4. So now my equation for this quadratic is going to be y equals a 0.25 x minus my first x-intercept, which was -4, so I'm going to put a +4, and then x minus 1. And this is the equation for that curve. Okay? So again, we're trying to find the equation for that graph. All right? So next, I want to write the equation for this new graph. Same idea. So I have y equals a parentheses, hold on, let me get my pen working here. X minus R1, X minus R2, and let's identify those x-intercepts. So my x-intercepts are at -1, 0, and at 2, 0. And now we need to find another point that hits really nicely, right? So if I follow my curve, I want to know where it hits the grid lines, like one of those little crosshairs. Right here is pretty good. Y-intercept looks like 0, 6. That's a pretty good point. Again, I'm trying not to approximate anything. I want to know exactly where it hits a nice point on the graph. So if I then substitute in these values, start with the x-intercepts. X, now it's a -1, so I'm going to say +1. And then x minus 2. Now we're going to plug in, remember, x and y, right? So the y value is 6. 0 plus 1, 0 minus 2. I got the 0 from that point. So let's start to reduce it. 0 plus 1 is 1. 0 minus 2 is a -2. So let's multiply those values together. So I'm going to get a 6 equals, now if you multiply, I get a -2a. And if you divide a -2, I get a to be 6 divided by -2 is a -3. So my equation is going to be y equals a -3 x minus my first x-intercept, so it'll be a +1, because remember it was a -1, and then I have x minus 2. this would be the equation for my quadratic. Okay? Let's keep going. So now I just give you kind of a verbal description. So just kind of saying, hey, these are the x-intercepts. This is the point that I want to use. Now, a lot of times these do come out to be decimals, but we'll kind of work through it little by little here. So I give you the x-intercepts, okay, and I give you a point, all right? So if I start with my equation, x minus r1, x minus r2, I'm going to start by plugging in the x-intercepts, okay? So I would have a y equals ax minus my first x-intercept was at 2, and then my other x-intercept is at a -4, so I'm going to say plus 4 in parentheses. But then they give me the point 1 comma -12. Remember, that is my x and my y value. So my y value is a -12, and then my x value is a 1. And if I solve this, I get a -12 equals, now let's try to figure out what these numbers are going to be. 1 minus 2 is a -1. 1 plus 4 is 5. So I get a -12 equals a -5a, again, because I'm just multiplying these values, dividing the -5. So I'm going to use my calculator here. -12 divided by a -5 gives me an a value of 2.4. Don't freak out if you get a little decimal there. That's okay. So my equation for this quadratic, given that description, is a 2.4, that's the a value, x minus my first x-intercept, which was at 2, so I used a -2, and then x plus 4. So this is the equation for my quadratic. I got another one. We're going to keep going. So I'm going to start with my formula. Again, factored form all day. A, x minus r1, x minus r2. I'm going to plug in my x-intercepts. So they give you the x-intercepts here. So y equals a, x, now it's a -3, so I'm going to say plus 3, and it's a +5, so I'm going to say -5. Okay. Then they give me this extra point, 2, 8. So the x is 2, the y is 8. So if the y is 8, that's where it's got to go. The x was 2. So I get 8 equals 2 plus 3 is 5. 2 minus 5 is a -3. So I can multiply these values together. So I get 8 equals 5 times -3 is a -15. Divide by a -15. We're going to get a decimal, but that's okay. I'm going to get an a value. I'm going to use my calculator. 8 divided by a -15 is a -0.53 repeating. Okay, so my equation is going to be that -0.53 repeating. If you want to put if you didn't put the repeating bar, that's fine. I would not mark that wrong. And then I'm going to say x minus my first x-intercept, and because it's negative, we're going to make it +3, and then I have an x minus 5. And this is the equation for the quadratic that has those x-intercepts and passes through that point. It is the only quadratic that has that, okay? All right, so I have a little word problem here. I'm going to show you that this is the same. Okay, it says Hector's dog, Ginger, competes in a waterfowl jump. She jumps from the edge of the water, catches a toy duck at a horizontal distance of 10 feet and a height of 2 feet above the water, and then lands in the water at a horizontal distance of 15 feet. Write a function. So I made a little picture here to help you understand. And I want you first I want you to see, like, I'm going to make like an X and a Y axis, right? I want you to understand, like, you can draw a coordinate plane on this picture. Okay. Now the dog is starting from the point 0, 0. Leaping up, catching a duck, landing, right? Now, it doesn't say that it catches the duck at the top. So I'm just going to say, hey, at 10 feet, right? After jumping 10 feet, catches it 2 feet above the water. So this point would be 10, 2. And then lands in the water 15 feet away. So this point would be 15, 0. Now I want you to see we have two x-intercepts. We have 0, 0, and we have 15, 0. So we can write the equation for this quadratic. Let me make my pen a little smaller here. I need room to write. There we go. All right. So I'm going to start with my formula. A x minus r1 x minus r2. I think the picture really helps me here because I know my x-intercepts are going to be at 0 and 15. And then I'm going to use this other point, this 10, 2 is my x and my y. So the y is 2 while the x is 10. So if I get 2 equals a, 10 minus 0 is just 10. And then 10 minus 15 is a negative 5. So I get 2 equals a, well, not a. What's 10 times negative 5? That's going to be a negative 50a. And then divide the negative 50. And I'm going to get a decimal. But I have 2 divided by a negative 50 is a negative 0.04. So my equation, I'm going to write it up here, is my a value, negative 0.04 times x minus my first x-intercept, which was 0, x minus my second x-intercept, which was 15. And ladies and gentlemen, there is the equation for my quadratic for that dog jumping. Okay? I have one more word problem because I know those are a little tougher for people. But if you notice, I just have to find the x-intercepts and a point, and I do everything the same. So Charlie kicks a soccer ball. So I'm going to draw a little Charlie. Here's his soccer ball. Kicks a soccer ball from the ground through a hoop that is 80 feet away at a height of 20. Okay, so it's kicking the soccer ball through a hoop, landing. Now, we don't know that that's at the top, okay? But we do know it says the ball hits the ground 100 feet, okay, away. Now, it's on the ground, so that's going to be at 0. It starts at 0, 0. I want you to understand I'm going to draw my x and y axis here, okay? So you guys can see my x-intercepts. Now, this point where it went through the hoop, it was 80 feet away and 20 feet up in the air. So if I write this equation for the quadratic, we have our x-intercepts and a point. So I'm going to start with the x-intercepts. I'm going to say a x minus 0. And then my other x-intercept is 100. Then I have this other point, this 80, 20. So x and y. So my y value is 20. All right. My x value is 80. So 80 minus 100. So now we just need to kind of reduce this a little bit. So 80 minus 0 is still 80. 80 minus 100 is negative 20. Now we're going to get a big number here, but don't freak out. So 80 times a negative 20 is a negative 1600a. And I'm going to divide by a negative 1600. So I get a to be a negative 0.0125. Okay, so my equation, I'm going to write it up here at the top, is y equals a negative 0.0125 x minus my first x-intercept, which was at 0, and then x minus my second x-intercept, which is at 100. And this would be the equation for my quadratic. Okay, hopefully that helped. That was my last slide. So again, we're just writing the equation for a quadratic in factored form. And when we do that, we need two x-intercepts, and we need a point, and then we can write our equation for that graph. Thank you.